Hello guys, welcome back. In today's video, we are looking at on how to determine Fourier series, and we are given this question to determine the Fourier series for the periodic function. We have this function which has got two options, which is -2 and +2. Uh, in the place of using -2, we have this range which is -pi. X, let's say x is greater than -pi, but less than 0. Okay, even here at the +2, we have this condition. X is greater than 0 but less than pi. Okay, and we are given another condition, which is this O question should be which is a periodic outside their range of period, which is 2 pi. So this range should be outside 2 pi. Okay, how do we go about this question? So let's get started. For solution, uh, for solution for solution so first of all, for you to know this range which they are talking about, you have to draw the graph. Okay, the graph will look like this one. Okay, the graph will be like this one here, which has got this is the one here, and this is positive, this is -1 at y axis. Okay, this is x axis. Then here you're going to have two values, which is -pi and the -2 pi. Okay, then here you're going to have positive pi and the 2 pi, because the range is saying we should end at 2 pi. Okay, so now we are going to draw this graph by following our range. Okay, so we are going to start this one from -2 pi. Okay, from -2 pi, you go up, you reach where 1 is. Okay, this is where you make a corner. Then you come down, you are going to cut -pi, then you reach where there is -1, you make a corner. Then you follow it up to where 1 is, then you make another corner. Then at pi, you make a corner, and another. At 2 pi, you make another corner. Okay, this is how graph should look like. Okay, but from this question, we are not to draw this graph. It is just there to help us to understand this question, because they are saying it is outside this range. It is outside this range. Okay, so now let's get started. For solution, since I've drawn this graph, as you can see, this is the graph I've drawn. So let me show you the procedure now. The procedure, we all know that the formula, it is f of x should be equals to sum of infinite as n approaches 0. We are going to have a sub 0 plus open bracket a n cos nx plus b n sin nx. Okay, this is how we go about our Fourier series. This is just a formula, and here we have dotted then one in the bracket. Okay, this is a formula used when you're solving a Fourier series. Okay, so now I'm going to show you the easiest way on how you can go about this question. Okay, so my procedure will be like this one. We are going to find a sub 0, a n, b n. Okay, we are going to find it step by step. Okay, so let's start with a sub 0. So a sub 0, this is the first option. A sub 0 should be equals to 1 over 2 pi. This is the range which we are given, 2 pi. Then 2 pi, then the integral of, then you follow this range. You have pi, this is a pi which we have, and the negative pi, okay, which is f over x dx, okay. So now let's move on to another step. The other step would be like, so let me just put it here where there's a light, okay, where there's light. We're going to be solving it here, okay. Then here we have this range here which you are seeing here. When you have -2, you're going to use this range, okay. So we are going to start with a sub 0 to be equals to 1 over 2 pi, then open bracket, minus 2. When you integrate -2, you're going to have -2x, okay. When you integrate -2x, then the integral of, where there is -2, we are going to use this range. So the upper limit, it is 0 here. Then the lower limit, it is minus pi, okay. Then you add plus this value which you are seeing here, which is when you integrate 2, you are going to have 2x, okay. Then the integral of, we are going to follow even this range. The upper limit, it is pi. Then the lower limit, it is 0, okay. It is 0. Then close bracket. Then now a sub 0, it will be equals to let's substitute now the values of x, okay. So in which we open, or here we have 1 over 2 pi, okay. Let me take it here. We have a sub 0 to be equals to 1 over 2 pi, open square bracket. Then we have minus 2. Then where there's x, we're going to put 0, the upper limit. Then you subtract the lower limit, which is -2. Then minus pi, okay. Then plus, here you're going to have 2. Then open bracket, where there's x, we have pi. Then minus 2, where there's x, we have 0, okay. You have 0. Then you close bracket, okay. This is how, here we are just finding a sub 0, okay. We are going to find a sub 0, a sub n, then b sub n, okay. So a sub 0, it will be equals to 1 over 2 pi, then open square bracket, then -2 times 0, you're going to have 0, minus then minus 2 times minus pi, you're going to have positive, because negative and negative positive, okay. Then this negative will come like the way it is, so you're going to have 2 pi, okay. Then plus here you're going to have 2 times pi, you're going to have 2 pi. Then minus 2 times 0, we are going to have 0, okay. In which a sub 0, it will be equals to 1 over 2 pi, then open bracket, minus 0 minus 2, you're going to have -2 pi, okay. Then plus 2 pi minus 0, you're going to have 2 pi, okay. Then in which it will be equals to 1 over 2 pi open bracket, minus 2 pi plus 2 pi, you are going to have 0 here. So a sub 0, it will be equals to 1 over 2 pi times 0, you're going to have 0. So we have found a sub 0, it is 0, okay? Let's find this one here, okay? Let's find an. So an, we are going to say a sub n, we are going to say 1 over pi, okay? Now we are using pi, okay? Then in the integral of minus of pi, positive pi, then minus pi f of, here we have f of x, we have cos n x dx, okay? Here we are finding an because a sub 0, we have found that it is 0, okay? In which an, so let's take it here. Let's take it here. So we have a n to be equals to 1 over pi, then the integral of pi minus pi, then f of x cos n x, okay? In which we are going to follow the same range which we have used here, okay? From a sub 0, okay? In which a sub n to be equals to 1 over pi, then open square bracket, then we are going to say when the derivative of cos, it is sine, okay? Here you are going to have, so we are going to use as this negative which you are seeing here. So you have minus 2 sine, when you integrate this one, 2 sine n x. X, it is already here, okay? If you want, you can take it here to be 2x sine n, okay? Then the integral of, you use this first condition here for minus 2, okay? For minus 2 here, it is the upper limit, it is 0, then minus pi, okay? Then plus you follow the other condition, which is 2 sine, because for cos we have find the derivative of cos, it is sine, okay? Sine n x, then the integral of, you follow this condition here, which is the upper limit, it is pi, then the lower limit, it is 0, then you close square bracket, okay? So a sub n, it will be equals to a sub n, should be like this one, a sub n 1 over pi, then open square bracket, then minus 2 sine, then open bracket, then here we have n times the upper limit, we have 0, okay? Then minus the lower limit, which is minus 2 sine n times minus pi, okay? Then plus the other condition here, because here we are only tabulating this one here. So now we are at this step here, okay? Then 2 sine, open bracket, n times which is pi, then close bracket, okay, then minus the lower limit, which is 2 pi, sine, open bracket, then n times 0, okay. Then here we all have n, because when you're integrating, the number which should be here should be divided throughout. Even here we have over n, okay. Then a sub n, it will be equals to 1 over pi, then open square bracket, then n times 0, we are going to have 0. Then sine 0, if you punch on calculator, sine 0, it is 0. So here you are going to have 0, okay, minus, then here here you are going to have n times pi, you are going to have n pi, okay, times this one, you are going to have 2 sine n pi, okay, because negative and negative goes, we remain with positive, okay, then you divide by n, okay, then plus here you are going to have also sine, so you're going to have 2 sine n pi, okay, then over n, okay, over this n here. Then here sine 0, it is 0, so here we have minus 0, okay. Then you close square bracket, then a sub n should be equals to 1 over pi, then open bracket, 0 minus 2 sine nx, you're going to have minus 2 sine nx, okay. If you want, you can put this one in bracket over n, then plus 2 sine nx in the bracket, then over n, okay, then you close bracket. Then a sub n should be equals to 1 over pi, then open bracket, minus 2 sine nx plus 2 sine nx over n, you're going to have 0 here, okay. Then a sub n should be equals to 1 over pi times 0, you're going to have 0. So a sub n, you have found that it is 0. So now let's find a sub, because we are following this formula here, okay. We are following this formula here. Since we have found a sub 0, it is equals to 0, and a sub n, we have found that it is 0 also. So we have to find b sub n, okay. So b sub n, it is saying we are going to have b sub n should be equals to 1 over pi, okay, then the integral of pi, then minus pi, then f of x cos or sine, because here we are following this bn. So sine n x dx, okay. Then here bn, it will be equals to 1 over pi, then open square bracket, then we are going to follow this condition also here, okay. we are going to follow this condition here for negative and positive. For negative, we are going to follow this factor here. Okay. Then when you integrate sine, you are going to have minus cos. Okay. Then here you are going to have minus the minus, which is already at 2. So you're going to have minus 2 cos n x, then close bracket, then you follow the range, which is the upper limit, it is 0, then the lower limit, it is minus pi, then plus open bracket 2. Here we have minus because the derivative of sine, it is negative cos. So we have negative 2 cos nx, then you follow the range, which is at positive 2. Okay, which is the upper limit, it is pi, then 0. Okay, then let's tabulate these values which we have here. Okay, you're going to have b sub n to be equals to 1 over pi, then open bracket, negative and negative goes, so we remain with positive. So you're going to have positive 2, then cos open bracket n times the upper limit, which is 0, then you divide by the same n. If it was a number like 2, 3, you divide it by the same number, which is here we have n. Okay, then minus 2 cos n times the lower limit, it is negative pi. Okay, limit, it is negative pi here, negative pi, then close bracket, then plus open bracket 2 cos open bracket n times the upper limit, which is pi, then you subtract the lower limit, which is minus 2 cos n times the lower limit, which is 0, then you close the square bracket. Okay, this is square bracket here, then over n. We do the same here, because here if there was a number, you are going to divide it by the same number when you are integrating. Okay, so here we have n. Okay, so now let's tabulate this one. N times 0, it is 0. Okay, and cos 0, it is 1. Okay, so here we have 1. So 1 times 2, so bn, it will be equals to 1 over pi, then open square bracket, then 2 times cos 0, here you are going to have 2. Okay, because cos 0, n times 0, it is 0. So cos 0, it is 1. 1 times 2, you're going to have 2 over n. Okay, then here, if you can see very well, here we have a negative here also. Here we have a negative, sorry, because here we have the negative, so here we have a negative also. So here we are going to have so here we are going to have n times the negative pi. Negative and negative goes, so we remain with the Let me see here. Oh, here it is positive. Negative times negative, which is positive. So here we have a negative. We have no negative here, okay? Then 2 times the n times the negative pi, you are going to have plus. Because of this negative which is here, so we are going to have positive here. So we have 2 we have 2 pi. We have 2 pi over n, okay? Over n. Then here we have n. Here we have pi n, okay? Then this one it is the let me say this one it is this one it is all together here, okay? The dash it is throughout. So here we have a positive, okay? Positive. Okay? Then here, this one here plus any times the pi, you're going to have because cos, let me say cos, this is the negative 180, okay? So cos 180, it is negative 1, okay? So cos 188 is negative 1. So here, the pi it is not shown because, let me show you the clear picture. B sub n should be equals to 1 over pi, then open bracket. Then here, cos 0, we say that it is 1. 1 times 2, we have 2 over, we have 2, here we have 2, okay? Then here we are going to have, because this one negative here, it is 180 at negative 180, okay? With this negative, we are going to have positive here. Then cos 180, we all know that it is 1, okay? So it is 1 times 2, you're going to have 2. You're going to have 2. Any, it can be any number. If you put any number, then you tabulate here. You tabulate a cos. This number which you have put, because when you're dealing with cos, we only deal with the odd numbers, okay? We only deal with the odd numbers, okay? Then here, you are going to have 2 plus 2 over n, okay? 2 plus 2 over n, then plus this one here, it is also 180, in which you are going to have 2 over n, then minus open bracket. Here cos 0, we all know that it is cos 0, it is 1, okay? Here, this one we have a negative here. So because of this negative, so we are going to have minus 2 over n, okay? Then bn, it will be equals to 1 over pi, then open bracket 2 plus 2. This one we can separate it as 2 over n plus 2 over n plus this one 2 over n. The negative times negative, which is positive, okay? So you're going to have plus 2 over n. Then you close brackets. Then bn should be equals to 1 over pi then open bracket 2 plus 2, because we are having the same common denominator, okay? Then 2 plus 2 plus 2 plus 2, you're going to have 8 over n, okay? 8 over n, then you close bracket, okay? Then here we are going to say now, we are going to follow this formula now. Where's the formula? This formula now. We are going to follow this formula because we have found that we are going to follow with the formula. We are going to follow this formula, which is f of x equals summation of infinite as n approaches 1. We have a sub 0 plus open bracket a n cos nx, then plus bn sin nx, okay? Then you close bracket. Now we have found these values. Here we have 0, then here we have 0 also. Then here we have found that we have, so we have f of x as the, so now we are going to say, we are going to have this one, because here we have a 0, because 0 times everything here you are going to have 0. So here we are dealing with the bn sin nx. So we have infinity of n approaches 1, you're going to have open bracket bn sin nx, and we have found that sin nx, we have found that it is f of x should be equals to, we have found that it is 1 over pi, then open bracket 8 over n. So we are going to, because when we're dealing with cos, we only deal with odd numbers. So odd numbers start from when n, so we're going to say when n equals, so the odd numbers start from 1, 3, 5, and 7. So we're going to use these numbers to substitute where there is n, okay? So it will be f of x to be equals to, when n it is 1, so we are going to have 8 here. So when n it is equals to 1, you're going to have 8. You're going to have, first of all, let's say we have 8 to come here, so we're going to have 8 over pi, then open bracket 1 over n, okay? 1 over n, in which this one it will be 8 over pi, then open bracket, then when you substitute n here with 1, you're going to have 1, then comma. When you substitute 3, you're going to have 1 over 3. When you substitute with 5, you're going to have 5, or you're going to have 1 over 5, okay? Then when you substitute it with the 7, where there's n, you're going to have 1 over 7. So this is a series which we are looking for, because we are taught to determine the Fourier series. So this is a series which we are looking for. So f of x should be equals to 8 over pi, then open bracket 1 comma 1 over 3, 1 over 5, comma 1 over 7. So this is a series which we are looking for, okay? Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you may see the new update. In the next video, we'll be looking at on how to solve exponential equation. For this video, we're only focusing on how to determine the Fourier series. Okay. See you next time. Bye bye.